right, and here are the notes for how to graph a polynomial. So pretty much we're going to take the leading coefficient test and the multiplicity and solving for zeros. We're going to put that all together so that we can make our graphs. Okay, so here are the steps to graphing. So for step one, you're going to determine the end behavior by using the leading coefficient test. And that's where we had that little chart. Let me see if I can draw that here for you. So I think this was positive and negative, and then we had odd and even. And again, we're talking about the degree. So positive, negative is the leading coefficient, and odd and even is representative of the degree. Okay, so if your degree is odd and your leading coefficient is positive, then from left to right, your graph goes up. So to the left, it falls, and to the right, it rises. If it is odd and negative, so your degree is odd, but your leading coefficient is negative, from left to right, it drops. So to the left, it rises, and to the right, it falls down. So think of that linear function. So positive goes up, negative goes down. For even, we know they both go in the same direction. So even degree, positive leading coefficient, both ends of the graph are going up. If it's negative and even, both ends are going down. So to the left it falls, to the right it falls. And if it's positive leading coefficient and even, to the left it rises, to the right it rises. So that's the leading coefficient test to determine the end behavior. Then we're going to set the equation equal to 0, and we're going to solve by factoring, however we're going to get that. You're going to determine the multiplicity. So you're going to look at the exponent of each factor. If you recall, if it is, let me see. Let's see, if it is, oh, it's right here. Determine the multiplicity, that's the degree of the factor. And determine if the graph crosses or touches and turns. So if it crosses the x-axis, it was an odd multiplicity. And if it touches and turns at the x-axis, that's going to be even. You'll determine your y-intercept by plugging in 0 for x and simplifying, and then you're going to graph it. All right, so let's take a look at a few examples here real quick. All right, so for the first one, for example 9, graphing a polynomial function. So first we're going to determine the end behavior. So we're going to find the highest degree, and we see that the degree is 4, which is even. And then we're going to look at the leading coefficient, and the number in front of this x that has the highest degree is a positive 1. So if you recall from earlier, if the degree is even and the leading coefficient is positive, then our end behavior, to the left it rises and to the right it rises. So it looks like this. So that's what our end behavior should look like for our graph. Now, for the X-intercepts, we're actually going to have to factor this. So I'm going to factor this just right over here. So I have 3 terms, so I'm going to attempt to do the X method. So let's just do this right here. So B is -2, A is 1, and then we do A, which is 1, times C, which is 1, which is 1. And then we have -1 minus 1. So -1 minus 1 is -2. -1 times -1 is 1. So this one becomes x squared minus 1. And the other one is x squared minus 1 as well. Okay. And it's squared because this is a 4, right? X squared times x squared is x to the 4th, and that's what we need. Now, this is 2 difference of 2 squares. So this one factors to x plus 1 times x minus 1, difference of 2 squares. And so does the other one, x plus 1 times x minus 1. So hopefully you notice there's 2x plus 1, so we can write this as x plus 1 squared, and the other one, x minus 1, is twice, so x minus 1 squared. Okay, so when looking at this, I can see that I actually have 2 x-intercepts. So for the first one, we're looking at this right here. So if I took x plus 1 and set that equal to 0, I would get x equals negative 1. And for the other one, if I took x minus 1 and set that equal to 0, I would get x equals positive 1. All right, for my multiplicity, for the first one, it was squared, which is even. And the second one was also squared, which is even. So pretty much even means it's going to touch and turn for both of them. All right. So first thing, then we got to find the y-intercept. Okay, so for the y-intercept, let's see, for the y-intercept, we plug in x is equal to 0. So like right here, f of x is actually y. So 0 to the 4th power minus 2 times 0 squared plus 1. So 0 to the 4th power is 0. Negative 2 times 0 squared is also 0 plus 1. So y is equal to 1. So 0, comma 1. All right, now what I'm going to do is I'm going to plot my intercepts, my x-intercepts on the graph, and my y-intercepts. So intercepts just includes all three of those. So negative 1, so I'm going to rough sketch it. So there's a negative 1 right there. X equals positive 1. We'll put that one here. And my y-intercept is 0, comma 1. Now, we're going to use this in behavior to kind of figure it out. So we know that our graph should start from here, and it comes down, right? This is the end behavior. This has to match that, which it does. Now, at this x-intercept, when I get to x equals negative 1, it's going to touch and turn. So I kind of make a curved line, come through here. We're going to cross the y-intercept. So the y-intercept we always cross. And then we bring it back down because here's our next root. So if it was odd, we would cross through it. But in this case, at x equals 1, it was an even multiplicity. So we're going to touch and turn. And then there's our graph. And you can notice the end behavior is the same. To the left, it rises. And to the right, it rises. Okay. And that's the first example there. Let's go ahead and take a look at the next example. Okay, so for this one, we'll do the same process. So when looking at this one here, in terms of our end behavior, we're going to look at the degree. So the highest degree is 3, which is odd. And then we're going to look at the leading coefficient. In this case, leading coefficient is 1, which is positive. All right, and then we refer back to our table in case you forget. So degree is odd, which is between these two, and the leading coefficient is positive. So to the left it falls, and to the right it rises. So we're just going to draw that in there. To the left it falls, and to the right it rises. So a linear line with a positive slope, pretty much. To get our x-intercepts, we are going to factor this. So when I look at x cubed and negative 3x squared, they're both divisible by x squared. So if I divide this by x squared and this by x squared, x cubed divided by x squared is x. And negative 3x squared divided by x squared is minus 3. All right, now for my x-intercepts, I set each one equal to 0. So take the square root of x squared, x is equal to 0. And for my next one, we take x minus 3, set that equal to 0, so we add the 3. And x equals positive 3. So for multiplicity, so for x equals 0, it was x squared. So you can see that is a 2, which means it is even. So at that root, it's going to touch and turn. At x equals 3, there's no number, so we assume it to be 1, which is odd. So that means that that x-intercept is going to cross the x-axis. And we don't have a third one, so we're not going to worry about that blank. Now to find the y-intercept, we do set x equal to 0. And we plug it in. So our equation is right here. So y equals 0 cubed minus 3 times 0 squared. So 0 minus 0 is 0. So our y-intercept is at 0, comma 0. Okay, so now let's go ahead and plot this stuff here. So my first x-intercept is at 0. My second x-intercept is at x equals 3. So 1, 2, 3. And my y-intercept happens to be where one of my zeros is. So that's not going to help me, or not going to give me another point to graph. Okay, so here we start from the end behavior. So we know to the left it's falling. So it looks something like that. Now we're going to come to this x-intercept. We're coming from the bottom left to that x-intercept. So at that x-intercept, it's at 0. So at x equals 0, it's even multiplicity. So we're going to touch it and turn. we come back down. And now I have to go back up because my x-intercept is up here. So at that one here, at x equals 3, it was odd, so we're going to cross the x-axis and come through. So you'll notice right here, to the left it falls, and to the right it rises. All right, let's go to our last two examples here. So for this one right here, it's already factored for us, which is great. So which means we just have to actually figure out our end behavior and then figure out our x-intercepts and our multiplicity. So for this one here, first off, we're gonna look at our degree. Now, be careful because these are multiplying, right? There is no plus sign separating them. These are all being multiplied. So in this case, we actually have to add up our degrees. So this doesn't have an x. This x actually has a degree of 2. This x has a degree of 1. So 2 plus 1 is 3. So our degree is 3, which is odd. Now, for our leading coefficient, we just look at the very front and we see that it's a -2, which means it is negative. So when we refer back to our chart, if the degree is odd and the leading coefficient is negative, to the left it rises and to the right it falls. So that negative slope of a linear line, if you think about it like that. Okay. Now for each x-intercept, we take what's factored in as an x, and we said equals, so x minus 1 equals 0. So if we add the 1, x equals 1. For the second one, x plus 2 equals 0. Subtract the 2, x equals -2. So those are my two solutions. For multiplicity, x minus 1 had a multiplicity of 2, which means it's even. So at that x-intercept, we're going to touch and turn at the x-axis. At x plus 2, we had an odd one, so 1, which is odd. So at that x-intercept, we're going to cross the x-axis. For the y-intercept, again, just like normal, we're going to plug in x equals 0. So y equals, now I'm just going to plug in, every time I see an x up here, I'm going to plug in a 0. So there you go. So we start with -2, parentheses, 0 minus 1 squared times 0 plus 2 to the first power. And at this point here, so we eliminate any possible mistakes. We're just going to simply type this into our graphing calculator so we don't make errors. Let's see. So we have -2, parentheses, 0 minus 1, close parentheses, squared, times 0 plus 2, close parentheses. And we see we get -4. So for right here, we know it's 0, comma, -4. All right, so just like before, I'm going to graph this information, and then I'm going to make my graph. So I have an x-intercept at x equals 1. I have one at -2, so -1, -2. And I have a y-intercept at -4, so 1, 2, 3, and 4. All right, so my graph starts from the top left. And once I get to -2, it's right here. It's odd, so I'm going to cross. Then I come over here and I go to that y-intercept. I'm going to make a curved line coming through it. And now I'm coming up to this root right here. So at x equals 1, it's even, so we're going to touch it and we're going to turn. And you just try to make it the best you can. Again, you can match your end behaviors. To the left, it rises. To the right, it falls. And there's my graph. Are we down to the last problem here? So again, we have this here. It's already factored for us. Again, be careful because it is being multiplied. Since it's being multiplied, we take the exponents, we add them. So this has a power of 2. This has a power of 1. So my degree is going to be 3, which is odd. My leading coefficient this time is a positive 2, which means it is positive. So we refer back over here to our little table. And by now you may already know it, but just to verify. So odd and positive, odd and positive. So to the left it falls, and to the right it rises. Okay, so we got that down. For our x-intercepts, we take x plus 2 squared, so just x plus 2. We set that equal to 0. If we subtract the 2, x equals -2. For the x minus 3, we set that equal to 0. We add the 3, x equals 3. So for x plus 2, the degree was 2, so the multiplicity is 2, which makes it even. So at that x-intercept, it's going to touch and turn. At x minus 3, it is a number 1, which is odd. So at that x-intercept, we're going to cross the x-axis. And then last, for the y-intercept, we're going to plug in 0 for x. So y equals 2 times, the first one's going to be 0 plus 2 squared. And the second one is 0 minus 3. You can plug this into a calculator and work it out. I'm pretty sure it is going to be, let's see, 2, 4, 8, maybe -24. But let's go to verify this just in case. So we have 2 parentheses 0 plus 2 close parentheses squared times 0 minus 3 close parentheses, and we do get -24. So 0, comma, -24. Now this is a rough sketch, so it's not, my graph is not gonna be accurate at all, but it's gonna be as close as I can make it. So for my first x-intercept is at -2, so -1, -2. My second one is at x equals 3, 1, 2, 3. And I know my y-intercept is at 0, -24, so let's say something down over here, okay? It's much further, but I'm gonna put it like that just so I can fit it onto this graph. All right, so I know I start from the bottom left. Once I get here, it's at -2. So x equals -2, it was even, so I'm gonna touch it and I'm gonna turn. And I'm gonna come down here, and I'm gonna pass through the y-intercept. I'm gonna come back up because my root is up here. Once I get here, I look at what it says. At x equals 3, it was odd, so I'm going to cross the x-axis and then make my graph. So to the left, it did fall, and to the right, it rose. Okay. So this concludes the notes for how to graph or sketch polynomials.